All right, so what I'm going to do is the lesson 2-6 and 2.7 part of the review packet. I'm going to do those proofs and I'm going to talk my way through them. So even if you're looking at the solutions and you're not quite sure about what's going on, this hopefully will help you out. First reminder on question 1 on the 2.6 is that over here, hopefully this isn't causing any confusion, the ij equals, and there wasn't anything there. So we'd mentioned in class, hopefully you heard us, that ij is also equal to 9. So both hi and ij are equal to 9. So I might even immediately start going to my drawing and jotting some of these things in. So hi and ij are both equal to 9, so I can jot those in. And I've also been told up here that ij, all right, well, maybe I'll even grab a highlighter. Let's use green. ij, okay, is congruent to jh. Okay, so let's highlight jh. Okay, so before I even start doing the proof, I'm seeing that what it eventually wants me to do is prove that hi, this side, is congruent to jh. Okay, well, that makes sense. I know that hi is 9. I know that ij is 9. I also know from up top here that ij and jh are congruent, so why don't I even put my markings in for those? I've been told that that's congruent with that. Now I want to show that hi, the yellow side, is congruent with jh. Well, that makes sense. It looks like I've already got an equilateral triangle. Now I just need to jot down my thoughts that are going to get me to those steps. As we've seen, the first two right there are going to be our givens. hi is equal to 9, ij is equal to 9. So for both of those first two, I can label them as given. Okay? Now, the next one says hi is equal to ij. All right, well, I don't have anything up here, so I know that's not a given, but up here I'm told that they're both equal to 9, right up here. So there's a couple different ways I can think about this, and I think I put both in the answer key. Well, if hi is equal to 9 and 9 is equal to ij, well, then we have that transitive property that says the first and the last. So we could title that the transitive property. Okay? Another way to think about it is, well, if hi is equal to 9, which we have, and 9 is equal to ij, well, then these two things are equivalent, and anything that's equivalent I can swap in and out. So I could substitute in the ij for the 9, giving me the equation down here. Those are two ways you can think about it. Substitution is one way, or the transitive property is the other way. So that's how either of those answers comes up as a possibility. Okay, the next step along the way is showing me, all right, let me grab the highlighter. Oops. Next step is showing me definition of congruent segments. Okay, we've seen in class, we've seen this one a few times. Basically, anytime I see definition of congruent segments, it's just that maneuver that we make when we change something that looks like this into something that looks like this. Instead of saying the distance from hi is equal to the distance of ij, we change it over to segment hi is congruent to segment ij. It's that. We've seen that before with angles. We've seen that before with segments. It's really just if you're already looking at a congruence, it's switching it to an equal sign. If it's already an equal sign, you're switching it to a congruence. But now I'm a little bit closer to where I want to be. hi is congruent to ij. Well, now it comes down here and it says ij is congruent to jh. Well, if we remember right, that is one of our givens. ij is congruent to jh. So again, I can simply write given because that is something that's provided to us. Okay, so now I have something right above it that says hi is congruent to ij, and I have something that says that ij is congruent to jh. Well, again, we're in a position where we can use either the transitive property or we can use substitution. If we're going to use the transitive, here's what it looks like. Okay, we've got ij is congruent to jh, and we've got jh segment is congruent to segment hi. All right, well, these two line up, so I can jump over them and just say the first and the last are congruent. So that's a way to use it, to get there using the transitive property. It also works with substitution again. If I know that ij is congruent to jh, and jh is the same as hi, well then jh and hi become interchangeable up here. Oops. And I can just turn this jh into an hi. Okay, that is doing it with substitution. All right, so that's how I would think through that. And it's not that dissimilar from how we would have looked at it to begin with. If we just started by looking at our shape up top here, we would say, well, why do I know that hi and jh have to be the same thing, which is what I'm trying to prove? Well, because we've got hi is 9, ij is 9, and ij is equal to jh, well, that tells me that that obviously must be 9, and if that one is 9, then they must all be equal. All we've done down here in the proof part is to walk through step by step in the factual order, giving justifications, so we are 100% confident that that is the outcome. Okay, so that's an example of how we would walk through that one. Let's go over to the next one. Okay, this is not dissimilar from one we did in class. We did something similar in class with supplementary angles. It's in the 2-7 notes if you want to take a look at those. Basically what we're saying here now, all right, let me get the highlighter back out, is that, all right, angle 3, this angle, and angle 2, this angle, are complementary. Okay, so what do I know about complementary? I know complementary add up to 90 degrees. Okay, so I'm going to process that. So those two add up to 90 degrees. Now I have another angle down here, angle 1, and I'm also told that angle 2 and angle 1 add up to 90 degrees. Okay, so I know that angle 3 and angle 2 add up to 90 degrees. And I know that angle 1 and angle 2 add up to 90 degrees. So I want to prove that 3 must be congruent to 1. Well, that makes sense, right? It makes sense because if we combine 3 and 2 and we get 90, and we combine 1 and 2 and we get 90, then 3 and 1 certainly have to be equal to each other. We can do that. We can do that as a proof. So let's just take it step by step, thinking about what rules we might use. So for our first step, we are told angle 3 and angle 2 are complementary. Well, that looks familiar because that was our first given. So for my first step, I would write given. All right, now I'm told in number 2, the measure of angle 1 and the measure of angle plus the measure of angle 2 is equal to 90. Well, there's my second given. So my first two are simply given. Okay, now we are told next, the measure of angle 3 plus the measure of angle 2 is equal to 90 degrees. Well, I'm not given that. I'm given that angle 3 and angle 2 are complementary. So now I'm making the assertion in number 3 that angle 3 and angle 2 add up to 90. Well, that's obvious, right? Why is it obvious? Because we were told they're complementary. And we know that complementary, by definition, means they add up to 90 degrees. So if we're thinking along the lines of, well, how can I justify this? It's just the definition of complementary, which is exactly why you and I both knew when we first saw that they added up to 90 degrees. So we're just going to write that. The definition of complementary. I apologize for my handwriting on this. It's not as good as I would hope. Complementary. Okay, that is the definition. We go from 1 to 3 simply by understanding that the definition of complementary angles is that they add up to 90, and now I'm making an assertion that they are 90, and I'm justifying it with the definition. Okay, so now, let me grab my highlighter again. I know a couple of different things. The first thing I know is that angle 1 plus angle 2 is equal to 90, and I know that angle 3 plus angle 2 is equal to 90. All right, well, here's what I've done now. I have taken angle 3 and angle 2 and put them on one side, and I have taken angle 1 and angle 2 and put them on the other side. Why could I do that? Again, either the transitive property, we can say that angle 1 plus angle 2 is 90, 90 is angle 3 plus angle 2, therefore we can skip the middleman of 90 degrees and just put them side by side, or I can use substitution. Either one is going to be an acceptable answer for that, just depending on how you see it better. So here is going to be transitive or substitution. Either way, when we have two statements that are both equal to the same, number, same degree, and then we just take either side and put them across the equal sign from each other, that's either going to be transitive or substitution. All right, so that's where I sit right now. I've got now measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. Now, on my next step along the way, it appears they have said now 1 is equal to 3. Well, how did they make that jump? Well, we took it from algebra. So we took it from algebra. Sorry, repeating myself. We've got M1 plus M2 is equal to M3 plus M2. Well, I've got something that's the same on either side of my equation. I've got M2 right there, and I've got M2 right there. Well, I know from algebra that if I have something the same on either side of the equation, I can simply subtract it from both sides, minus the measure of angle 2, minus the measure of angle 2. And when I do that, they cancel out. And what am I left with? I'm left with the measure of angle 1 is equal to the measure of angle 3. And since I subtracted the same thing from both sides, that is my subtraction property. Okay, so now I'm down to the measure of angle 1 is equal to the measure of angle 3. And just like above, I'm at that step, right? That step where I go from an equal sign to a congruent sign. On top, we did it vice versa. We went from, we went the same direction. We're going from an equal to a congruence. Or if we're going from a congruence to an equals, all we say is, well, that's the definition. Ooh, that's the highlighter. All we say there is that is simply the definition of congruence. If two things are equal, then they are congruent. If two things are congruent, then that means that they are equal. Sorry, that is supposed to say congruence, but again, I apologize for my handwriting. So that's the first page. So an example of the first two. Let me shrink this down and grab The second page will go through those. Okay, all right, perfect. Now I've got one that is dealing with segments. So again, before I even start, I just want to look at this. And I want to say, okay, does it make sense? Oh, and how would I go about saying this? All right, so let me grab my highlighter. AL is equal to SK, okay? I'm being told that those two things are equal, so why don't I go ahead and mark them? Why don't I go ahead and mark them for myself? AL and SK are equal, okay? I want to prove in the end that this distance, A to S, is the same as this distance from L to K. Okay, well, if I look at that, that makes complete sense. I know AL is the exact same length as SK, and if I add that piece in the middle to both of them, they're the bigger piece, the combined pieces, of course are going to be equal. So I know that's basically what I'm going to be showing, is that if I add the same thing to both of the small segments, my bigger segments are going to be equal. We can do that. So first step is AL is equal to SK. Not surprisingly, the first thing that is provided is our given. Okay. Now, my next step says LS is equal to LS. All right, well, that makes sense because that's what we were thinking when we were looking at this. The middle piece is the same length as itself, the reflexive property. So we can go ahead and over here and write down reflexive. But this is going along the exact same logic that we were thinking through before we even started the proof. If I've got two small pieces that are the same length, and I add a big piece, the same big piece, to both of the small ones, of course it's going to end up being equal. Okay? But if we're doing this proof, we want to say that is the reflexive property. Something is equal to itself. Okay, so my next point here down the line says AL plus LS. Okay, so AL plus LS, so the blue plus the green, is equal to LS, the green, plus SK. All right, well, that makes sense. Now the question is, how did we get there? Okay, how did we get there? We know it's got to be true. So if you have a question about how it got there, look at the steps above. And here's all that happened. We had the fact that AL was equal to SK. We next pointed out the fact that, well, LS is equal to LS. And we have that addition rule, right? The one we were using in algebra for all these years. If we add the same thing to both sides, it's still equal. I can do that. We can do that. We can add a number to both sides of our equation, and as long as we do it to both sides and it was equal to begin with, it's still equal. Well, that's all we did here. We combined the AL with an LS, we combined the SK with an LS. If AL and SK were equal in the first place, they're still equal now, which is our addition property. Okay? When we add the same thing to both sides, that is our addition property. Okay? So now let's take a look. All right, so I see where they got that. Now they're telling me that AL, oops, let me erase that. I don't have my highlighter. Okay, grab the highlighter. AL plus LS is equal to AS. Okay, well, that's what we were talking about up here, right? AS is the longer segment that's created when we combine the two. So AL plus LS is equal to AS. Okay, this is a property we haven't used yet in these examples, but we've definitely seen. And early on, especially now, most of our properties are fairly intuitive by their name. Well, I have a segment, and I added another segment to it to make a longer segment. That is the, drumroll, segment addition postulate. Okay, that is segment addition. You have a segment, you add another segment to make a longer segment, segment addition. Not surprisingly then, down here, oops, oh, okay, grab the highlighter, SK from up here plus the middle part is equal to our longer segment, right? Is equal to this segment that we were talking about. LS and SK create LK. And again, we added two smaller segments together to get the longer segment. Well, if I'm adding segments, then this must be my segment addition postulate. Okay, so I've added segments, Well, now at my final step, I've gotten to the thing that I wanted to prove, which is great. How did I get there? Well, if you notice what we had in 3. Okay, 3 said AL plus LS was equal to SK plus LS. Well, now in number 4, I have shown that AL plus LS, the thing that is on the left side of our equation in number 3, can also be called AS, right? AL plus LS created a longer segment. So what did I do? I substituted in AS for the left side of my equation in 3. It's a shorter form, right? AL plus LS is just AS. In 5, I defined that SK plus LS, okay, so this short segment on this side plus LS makes the longer certain segment LK. Well, that's the same thing. So I took it from my formula up here and I substituted in LK. And where did I get? The fact that AS is equal to LK. And that final step is just substitution. I had two things that were equal. I swapped in the longer segment instead of talking about both of the shorter segments being added together. Okay, hopefully that helps to kind of think these things through. All right, next one. Again, let's think about it before we jump in. Given the measure of angle 4 is 120 degrees. Okay, so I'm just going to write that down right now. The measure of angle 4 is 120 degrees. Okay. Angle 2 is congruent to angle 5. Okay, well, angle 2 and angle 5 are congruent, so why don't I put a swoop on each one to help me remember that those two are equal. And then another given, angle 4 is congruent to angle 5. Okay, well, angle 4 is congruent to angle 5. Okay, well, that makes sense. Now I want to show that angle 2 is equal to 120. Well, it seems obvious now, doesn't it? If we're looking at this shape and we say if angle 4 is 120 and angle 4 and angle 5 are the same, well, then angle 5 must be 120. And then if angle 2 and angle 5 are the same, well, if 5 is 120 and 2 is the same, it must be 120 as well. So my conclusion makes sense. But that's the thought process that we want to lay out, is exactly each one of those steps in order. So that's what our proof is very likely going to look like. Angle 4 is 120, 2 and 5 are congruent, 4 and 5 are congruent. Those are all of our givens right at the beginning. So what else did I say? I said, well, angle 2 and angle 5 and angle 4 and angle 5 are equal to each other. Okay, well, what do I know? I know that I have the transitive property or substitution again. Either way works, but if I line these up, angle 2 is congruent to angle 5, and angle 5 is congruent to angle 4. I just flip this around. I've got my symmetric property. Well, again, that's just transitive, right? If A is equal to B and B is equal to C, then I can get rid of the B's and say that A is congruent with C. That's exactly what we did there, right? Transitive, if you see it better as substitution, where I know that 2 is the same as 5 and 4 is the same as 5, so I can just swap in 4 in for 5 since they're equivalent. Substitution is also a good answer. So here you could have transitive or you could have substitution. Either one will work. Okay, all right, I've got two angles saying they're congruent. I have that definition of congruent angles. When do we ever see something that says definition of congruent angles? Only when we are just swapping a congruent sign into an equal or an equal into a congruence. So since I'm starting with a congruent sign and I want to go and I want to use the definition of congruence, I'm simply just going to say the measure of angle 2 is equal to the measure of angle 4. That's really the only time we use that definition of congruent angles, definition of congruent segments. Anytime we have the definition of congruence, all we're doing is swapping from a congruent to an equal or an equal to our congruence. Okay? And why do we need to switch from a congruence to an equals? Well, because what we're trying to prove has our equal sign. So we need to switch it at some point along the way to make sure that we get an equal sign in our proof. All right, well now, if the measure of angle 2 is equal to the measure of angle 4, as I said in 3, and I know from right up here that the measure of angle 4 is 120 degrees, well, I can just swap that in right there. The measure of angle 2 is equal to the measure of angle 4. Another way to write the measure of angle 4 is simply 120 degrees, so I can swap it right in. Again, that could be transitive property, that could be substitution. Either way works. Transitive, or substitution. Okay, so there's another. Again, I apologize for the handwriting. I need to figure out how to get my better pen to work on this iPad. All right, so hopefully that kind of shows you some of the thought process. All right, the next one I know, ooh, why isn't my writing staying with my steps there? Okay, I'm not sure, but I'm going to go ahead and erase it. Hopefully you've got it jotted down. If not, pause the video, go back so you can see if you don't have everything jotted down there. Again, I apologize. It's the first time I have used this, so I will try to make it better in the future, but I do want to talk to this one down here. All right, so okay. So this one is one of these algebraic proofs that we've done. But here's what I know. I know in this particular problem that angle W is congruent to angle Z. Well, definition of congruence would tell me as well that the degrees of angle W are equal to the measure or the degrees of angle Z. Okay? Well, if I know this is equal to this, then I know that 11x minus 8 is equal to 9x plus 4. Okay, let me get a black pen because that one's hard to see. 11x minus 8 is equal to 9x plus 4. All right, well, let's do our algebraic proof. First off, I'm going to add 8 to both sides. Why am I allowed to add a number to both sides? As long as it's the same number, that is our addition postulate. Okay, that cancels to 0. 11x is equal to 9x plus 12. Okay, all right, well now I'm going to subtract 9x from both sides. And I can subtract the same thing from both sides and it remains equal using the subtraction postulate. 9x cancels on the right. 2x is equal to 12. I'm going to divide both sides by 2 using my division postulate. And x is equal to 6. Okay? Solve for x. That's what it's asking me to do. If it had said, what is the angle measure? I would then come back, plug 6 in, and find the measure of each of the angles after I subbed it in for x. Here it's just asking for x, so my final answer would simply be x is equal, don't like how that looks, x is equal, that got worse, x is equal to 6. I set them equal to each other to get there, and then I provided my rationales when it says explain your steps. That is one of our algebraic proofs. All right, so let me go ahead and erase these and get back to the third page so we can take a look at those last couple of proofs. All right. Okay. Bring down our third page here. All right, which takes us to our last page. And let's erase this up here. Okay. Okay, let's move it up here. And, all right, sorry for the delay, but here we go. All right, last page. All right, I am given that angle 1, I apologize, angle 2 seems to have gotten slow here. Angle 2 is congruent to angle 3. That is our given. And what I end up wanting to show is that angle 1 is equal to angle 4. Okay, so I'm going to pause again before I even start the proof and take a look. If I know that 2 and 3 are equal to each other, and I want to show that 1 and 4 are equal to each other, I'm going to think it through and say, yeah, I can do that. If I know 3, if I start with 3, I can definitely say that that's equal to 4 because they're vertical angles. And if I'm looking at 2, I can definitely say that that's equal to 1 because of vertical angles. And if 2 and 3 are equal, then 1 must equal 4 because they're all going to end up being the same angle. So that's the approach I want to go through. So let's see how they walk through those exact same steps as we just talked about. First one, not surprisingly, angle 2 is congruent to angle 3. That is our given. Okay? So then it comes and it says angle 3 is congruent to angle 4. Oh, we just talked about that. We know that's true. And how do we know that's true? Well, that is because of vertical angles. Vertical angles tell us that angles that form this V that are looking directly across at each other are always congruent. Okay? Well, angle 2 is congruent to angle 4. Well, that's not vertical angles, but we can get there. We can definitely get there by, again, either substitution or transitivity. How do we do it? Well, if angle 2 is congruent to angle 3, I'm going to go to black again. The other ones aren't even very legible. If angle 2 is congruent to angle 3, as we found in our given, and if we use vertical angles to say that angle 3 is congruent to angle 4, well, that's just transitive, right? If A is equal to B and B is equal to C, well, I can skip the middleman and go straight from A to C. A to C. So that's either the transitive property or we can use substitution. Either one is a justification for that. All right, well, next step 4 says these two are equal to each other, 1 and 2. Well, we talked about that before we even started the proof. That's just vertical angles again. Okay, well, that's vertical angles. So now I know 3 is equal to 4. I know that 2 is equal to 4. And now I know that 1 is equal to 2. Well, if 4 equals 3, and 3 equals 2, and 2 equals 1, then 4 must be equal to 1. That's just like a gigantic transitive. So again, I'm hopping through, and I'm saying that the transitive property allows me to pass that value from angle to angle. Okay? 3 is equal to 4 in step 2. 2 is equal to 4 in step 3. 1 is equal to 2, and now that I have tied that link together, I can say 1 is equal to 4 through the transitive property. All right, and let me scroll up here. Oh, this again. Okay, let's look at this last one in the packet. Okay, so I'm going to grab my highlighters to help me kind of take a look at 1 and 2 are complementary. Okay, if 1 and 2 are complementary, that means they must equal 90 degrees, so that's definitely going to come early in my proof. Okay, now it says even further that 1 is equal to 3. Okay, well, why don't I just use the same color for 1 and 3 then? If they're equal, if they're congruent, why don't I just use the same color? And now they're saying 2 is congruent to 4, so why don't I use the same color there? And what is it trying to ask me? It's trying to say, to prove that, let's grab a pen here, that 3 and 4 form a right angle and are complementary. Well, that makes sense. That makes sense for a few different ways, right? If 1 and 2 are complementary, they add up to 90 degrees. Okay, so angle 1 plus angle 2 add up to 90 degrees. Well, if 1 is equal to 3, then they're the same amount of degrees. And if 2 is congruent to 4, then they're the same amount of degrees. And if 1 and 2 added up to 90, then 3 and 4 must add up to 90. Okay, we can get there. That's logic, but we can get there. So 1 and 2 are complementary. That's straight from our given. Okay, 1 plus the measure of angle 1 plus the measure of angle 2 is equal to 90. Well, that's not part of our given, but it's obvious. Why is it obvious? Because that's the definition of the word complementary, right? We knew that. As soon as we saw that angle 1 and 2 are complementary, we knew that that meant they added up to 90 degrees. We learned that in chapter 1. Complementary means 90 degrees. So that is simply definition of complementary angles. Okay? And I just shorthand the angles there. All right, now angle 1 is congruent to 3 and 2 is congruent to 4. That's again back from our given. That started out our problem. All right. Oh, what did they do? They said the measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4. Well, that doesn't really say anything different from 3, does it? But what did it do? It changed our congruent sign into an equal sign. What do we say happens when we change a congruence into an equals or an equals into a congruence? Well, that is always just the definition of congruence, right? If two things are equal, then they're congruent. If they're congruent, then they are equal. So that is just the definition of congruence. And again, I'm apologizing again, simply not working well for writing on this. Okay, so next step. Angle 3 plus angle 2 is equal to 90. Well, where did they get that? If I'm looking at this, there's nothing that they told me up on my graph. Like they didn't put, it's not there. They didn't put like a sign that looks like that on between 3 and 2. So I can't use that just to say. So I'm going to go ahead and pull that back off. Where could they have gotten it? Well, let's look at what we have established here. We have established that 1 plus 2 was equal to 90, and we have established that 1 is equal to 3. 1 plus 2 is equal to 90. 1 and 3 are the same thing. That is substitution, right? 1 is the same thing as 3, so we can put them in there interchangeably. So we just took the equation we had, number 2, we swapped out the 1, swapped in the 3, and there is our, and we can do that by substitution. Okay, so those two are equal to 90. All right, well, now what did we do going from 5 to 6? Okay, we carried our 3 down there, but we turned our 2 into a 4. How can I turn that 2 into a 4? Well, we've got it up there, right here. 2 is equal to 4. All right, well, we already had our 3. We swapped this 2 in for that 4, or swapped in the 4, replaced it with that 2. What rule allows us to swap in something that's equal? That means exactly the same thing. Again, it's substitution. So we just swapped in a couple of times things that were equivalent to each other. And now we have the measure of angle 3 plus the measure of angle 4 is equal to 90 degrees. Okay, that's pretty darn close to what we're looking for, right? That is pretty close. We wanted to prove up here that angles 3 and 4 were complementary. We've got angle 3 plus measure of angle 3 plus 4 equals 90 degrees. That's pretty darn close, but it's not quite there yet. What do we have to do? Well, we have to actually have the last line match up with what we're trying to prove. And how do I know that if they equal 90, then I can call them complementary? Just right back to the definition of complementary angles, right? We know complementary angles mean they're 90 degrees. 90 degrees mean they're complementary. So we used it going from 1 to 2 to turn complementary into 90 degrees, and we used it between 6 and 7 to turn 90 degrees back into the word complementary. All right, so hopefully these explanations will kind of help you through some of the proofs and maybe give you a little better understanding of how to think through some of these. We'll do some review on Monday before the quiz, and all the problems on the quiz that you're going to see on Monday that relate to proofs are going to give you either the statement or the reason, and you will just try to fill in the other one. So you'll still work on that. We'll continue to review on Tuesday, and then we'll have the test on Wednesday. So we'll talk a little bit more about that. Have a great rest of the weekend, and I hope the video helped. I don't know what just happened there, and I'm hoping I can fix it.